Missed an episode of your favorite podcast? Choose from over a decade of content in our archives, not just the latest episode. All free at GCNlive.com.
This is your call to action. Get prepared, America. Economy, survival, energy, disasters. This is USAPrepares.com. Informative radio, educational radio. Interact now by emailing instructor@USAPrepares.com or text at 434-390-7953. Class, please take your seats. Now, your instructor, Vincent Finelli.
Everyone all set, cocked, locked, here we go. Your dial set correctly to USA Prepares. Thank you for being in class with us today. Jason, thank you for engineering the broadcast. Kyle, welcome.
Good morning, Vince. How are you?
Good morning. Good morning, Kyle. We're going to be talking about tires and carburetors and spark plugs and automotive technology in class. If you're interested in asking us a question about preparedness, please give us a call, 866-582-9933, 866-582-9933. Now, as a disclaimer, I don't think you should believe anything that you hear on the radio or in the media. You should do your own research. Do your own research. Today is a special day. It's April 1st, 2021, in the year of our Lord. April 1st, 2021. And April 1st is a day of special significance to some of us here at USA Prepares and some of us in the broadcast classroom. Once annually, USA Prepares selects a press release of content worthy of introspection. I have in front of me a press release meeting the de facto criteria established by the current mainstream media. Kyle, if you don't mind, bear with me for just a few minutes. I'd like to read this press release. Sure. So I'm going to quote. Here is the press release in its printed form. Quote, April 1, 2021, U.S. Newswire's release. The ITU, our Committee for 6G Next Generation Cellular Communications, today announced the UX bus. Embedded 6G standard, the latest innovation in cellular technology. Adopting the proposal from PASU Computers, Santa Rosa, California, a fully operational UX Direct Connect wireless cellular interface was demonstrated at the recent 3GPP IEEE planetary meeting in Geneva, Switzerland. Outstanding researchers in the computer, networking, wireless, and medical fields who teamed together to develop the system were present to share the product's unveiling. The revolutionary architecture sports the UX interface, allowing complete control of all physical, transpositional, and MAC layer operations through a bio-interface layer, to be named Layer O on the OSI chart. Layer O is denoted to reference Layer O, or origin layer. This strategy was driven when engineers recognized that no present microprocessor bus could address data faster than the human mind. According to the radio designers J. Sinotreb, Sinotreb, and V. Illenif, Illenif, the UX bus operates at a maximum data rate of 254 gigabits per second and is fully OC3 and FCC Part 15 compliant. All relevant spectrum compliant and quasi-interface levels have been shielded and meet the 2021 UL and CSA standards. Considering current 5G radio transceiver limitations, the UX bus provides an effective, direct, and non-line of sight solution and requires no Faraday reluctance. The UX system is available with both implanted internal microstrip and external top hat scaffolding antennae. Although the first prototype installation was performed in the sanitary facility of Walter Reed Army Hospital, PASU Computers is confident that a new step-by-step internet video will allow on-site installation in only 4 hours' time by most general surgeons. All hardware including 13 Teflon-coated stainless steel self-tapping screws, stainless steel micro-star tool drivers, and reusable ratchet and are pre-sterilized and included for installation. The 20-page instruction manual is written in a format which both professionals and do-it-yourselfers can easily follow. PASU Computers requires completion and online certification of competency for the do-it-yourselfers. All pages are plasticized and easily wiped clean with a damp cloth. A toll-free hotline is provided should any medical complications occur. First production units are scheduled for early June. Pricing has not been established. Annual license renewals are available for those desiring to continue to use the UX bus for each additional year. For more information on the UX bus, contact PASU Computers, Santa Rosa, California. And for information on the 3GPP IEEE wireless networking standard, go to www.standards, standards.ieee.org. End quote. So that is the press release that we thought had content worthy of introspection here on April 1st, 2021. USA Prepares. Kyle, we're going to be talking about cars, carburetors, and we'll take your calls. I've got the call screen in front of me. Class 866-582-9933. Should you desire to call us and ask us your questions, cars, tires, preparedness in general, solar, plumbing, heating, electrical, you name it, in the preparedness aisle, that's what we're here for. We are not going to be discussing politics today. There are plenty of broadcasts that let you call in and vent about something that you can't fix, and that would be politics. Kyle, welcome. Your thoughts?
Good morning. You know, it's interesting about the press release, Vince. This last week, I was doing some study of my own, and I come across a paper that was dealing with 5G and the vaccination schedule for the country. And it was literally saying the closer after you get vaccinated, within 2 to 6 weeks after being vaccinated, the closer you get to a 5G tower, the more peaceful, compliant, and docile our population will become. I thought that was an interesting side note into this. But you have to be fairly close to the 5G, where the 6G, I guess, with that, what I was listening to there, you do not need line of sight or that closeness.
Yeah, and that press release, class, if you'd like to listen to it again, just go to the Ron Gibson channel on YouTube or BitChute, or go to GCN Live, GCNLIVE.com, and you can click on USA Prepares, archives, download it, listen to it over and over, and dissect it if you'd like. And if you have some comments about that particular press release, I'd love to hear them, and you can send them to me at instructor@usaprepares.com, USAPREPARES.com, instructor@usaprepares.com. So, Kyle, one of the things that we're going to talk about is this mess that our government has created with gasoline. And by adding alcohol, which would be food from corn, added to gasoline at the pump, it has caused all kinds of problems with fuel systems. We have cars here that, you try to store them, and if you don't remove all the gasoline, the gasoline alcohol mixture will corrode the fuel system, and it will be a very expensive repair. And that's just, cars. But then if you go into like lawnmowers, the single cylinder engines with the small carburetor and the gas tank above the carburetor, and the carburetor above the cylinder, what happens is the gasoline corrodes part of the carburetor. The needle and seat leak. Gasoline comes from the gas tank, drip, drip, drip through the carburetor into the intake port, through the intake valve, into the cylinder, and dilutes the oil that's in the crankcase that lubricates the engine. And that diluted engine oil does not have the lubricity that it once had before it was diluted. And by starting that engine within 20 minutes, you can easily, permanently, irreparably destroy that engine. So what you need to do is every time you start your lawnmower, rototiller, or small gasoline engine-powered device, you need to make sure that you check the oil. And if the oil level is higher than it should be, that means gasoline has dripped down and increased the height of the oil level. And you can smell it. If they have a little dipstick, you can smell the oil, and you might smell gasoline. If you do, you need to drain out that oil, fix the problem with the carburetor, because it will continue to drip, and you will destroy that engine. So you don't need to destroy your engine. All you have to do is check the oil level. And if it's higher than it should be, higher than it was the last time you checked it, then you have probably got this gasoline leak coming from the carburetor through the intake port, through or past the intake valve, into the combustion cylinder, a combustion chamber, if you will, past the rings of the piston into the crankcase. And it's all downhill. So you start with the gas tank on top, then below that is the carburetor, then below that's the intake port, then below that is the cylinder, then below that are the rings, the piston and rings, and then below that is the oil crankcase. And you know that you would never pour gasoline into the engine oil reservoir or the crankcase. You know that. Well, that's what happens, and your government has allowed all of this to happen by forcing you to buy at the pump, in most places, gasoline that's mixed with alcohol, 10% alcohol. Kyle?
I absolutely hate the stuff. Yeah, I will only rent it in vehicles that I am driving all the time. Literally, I will put that in, just the plain Jane gas into the cars that are just fuel injected or running, that I run all the time. I had personally never, ever, never put ethanol gasoline in anything carbureted, or I don't even put it into anything that's going to be setting for more than like a week or two at the most. Otherwise, I keep all of the trucks that I have that I'm not necessarily using all the time, like my snowplow truck will set most of the summer. That has nothing in it but ethanol gasoline mixed with seafoam, 1 ounce per gallon added for a preservative, and it'll start right up and run fine right away every year. And the same thing is true like on my two-stroke engines. I just fired up both of my chainsaws this last week, again, with nothing but pure non-ethanol gasoline in it with 1 ounce per gallon of seafoam. And within 3 to 4 pulls, they were both running excellent. But I did always, I put the chainsaw on its side there, the way you fill them, and I opened the port and I smell the gasoline because it's one of those things that I just don't want to take a chance on. I can't afford to replace the saw.
Mm-hmm. Very well said. And very quickly before we go, when we come back from the break, what's the delta in cost between the 87 10% alcohol gasoline and the non-ethanol gasoline? When we come back, please share that with us. Kyle's with us. Kyle, so you buy pure gasoline without ethanol added as mandated by the government. That's a specialty gasoline. It's not available at most pumps. What is the cost difference between pure gasoline and ethanol and gasoline blended?
Well, it runs around here. The regular gasoline with ethanol in it is approximately $2.65 a gallon. And when you buy the non-ethanol gasoline, right now it's running $3.39. So they pay you more, or they charge you more for doing less.
Yeah. So it's a substantial price increase, but you're not using that much in a chainsaw, just a few gallons a year, right?
Right. Correct. Uh-huh.
Mm-hmm. Mm-hmm. So it might cost you $3, $4, $5 extra per year to do that, But what you save, if you save that $3, $4, $5 extra that you spend will save you from buying a carburetor and having these other problems that most people are going to enjoy when they try to start their lawnmower this season. And what they're going to find out is that riding lawnmower won't start, and that self-propelled lawnmower won't start, and that rototiller won't start for the reasons that I've mentioned. And so what they'll get a chance to do is either have it picked up by the company that services small engines and lawnmowers, or get that piece of equipment to the company that services them, and then they'll find out that oh yeah, no problem, we know how to fix this. This is easy. All we do is wipe out the gas tank, rinse it out with solvent. So we take the gas tank out, we'll put new fuel lines in, a new fuel filter in, we'll put a shutoff valve in for you, because your equipment doesn't have any of that. And we will also replace the carburetor and put a new spark plug in it, and we'll test it, and we'll change the oil for you. And $140, $150 later, you're all set, except for the transportation. I think that's what most people are going to hear, minimum, unless they have a twin-cylinder engine, which has a way more expensive carburetor. Any comments on that, Kyle?
No, that's exactly correct, Vince. And I'm thinking you're on the low side. I'm thinking, and which I think that's probably what you would charge, if you were there. But that's a cheap price, actually. I would bet it's closer to $250 to do all of that work with the way labor is going now. I mean, I don't know about where you are, Vince, but labor in these automotive here now are $100 an hour for Joe Blow mechanic, and $75 for somebody doing it in a shop out in the middle of the woods, practically. So I don't know what you guys are at around your area, but it's terrible.
I'll tell you, Mercedes-Benz charges around $120 an hour. Most mechanics charge around $100, and we charge $48.80. And then, if we think that the bill is too high, we reduce it. We just say, it's ridiculous. That shouldn't have cost $100, for 2 hours. Let's make it $50. I mean, that's the kind of things that we do. And we just, we try to put ourselves in the other person's position. And that's why people come to us. That's why there's absolutely no advertising whatsoever. And, here at the farm, when we fix large tractors and small tractors and golf carts and lawnmowers and generators and chainsaws and of course cars and trucks. And we do welding, and we do all those things, and we do it because we like to, and because we like the customers that we have here. But if we don't like somebody, we're not going to do it. We're kind of unusual that way. No, really. And when we had our company back in Virginia, a guy came into to our little factory, and he said he had a business and he wanted us to build a computer network for him. And I asked him about his business, and he said, well, it's in a house, and he's got 2 stories, and he needed a network and about 5 computers and networking and printing. And I said, yeah, okay, that's not a problem. And I said, so what do you guys do? He said he was a lawyer. And I said, we have a company policy, we have a corporate policy, we don't work for lawyers. He thought I was kidding. And I said, no, I know about lawyers. You guys, you're naturally argumentative, and you look for reasons, you look for faults, and then you go to school and you learn how to enhance that argumentative ability. And so I said, I don't think you'll be happy. So we can't help you. He thought I was kidding. I was not kidding.
Oh, man. So,
absolutely true. When we come back, Kyle, let's talk about tire balancing, if that's all right with you. And, there's a way of balancing tires with wheel weights. That's what we do. And that would, permanently balance the tires, or relatively permanently. And then there's a way of doing it with little beads, little ceramic beads. We'll talk about that when we come back. Kyle's at the blackboard at the head of the classroom today. And we're talking about preparedness and automotive technology. We're talking about tires and wheels and carburetors and so forth. And if you'd like to call us and ask us your question, 866-582-9933, 866-582-9933. I mentioned previously on a broadcast with Kyle that I was trained how to statically balance tires when I was an employee at Sears Roebuck & Company after school hours when I was in high school. And the idea was that you wanted your tire and wheel assembly to be in perfect balance so that it would not vibrate and cause undue damage, undue wear and stress and strain on your suspension system. Cause the shock absorbers to wear out more quickly, cause the tie rod ends, the ball joints, everything to wear out more quickly if you had unbalanced wheels. So I was taught how to properly balance tires and wheel assemblies. And when I say assembly, I mean, the tire is separate, the wheel is separate. But when you put them together, you have an assembly. And the tire is out of balance all by itself. The wheel is out of balance all by itself. And when you put them together, you can minimize the out of balance condition of the tire and the wheel by putting the heavy part of the wheel against the light part of the tire. Okay, you can orient it that way. And that's how we balance tires and wheel assemblies right here at the farm. So there's another way of balancing tires, and that is with these ceramic beads. Now, these little beads are like BBs, a little bit smaller than a BB, kind of like a skeet shot from a shotgun shell. That's what we're talking about. But they're not made out of lead, and they're not made out of steel. They're made out of a ceramic material, and they are spherical. And what you do if you're using these, or what the tire guy does, is he'll throw either a scoop or a number of pre-weighed packets. Think of it like seasoning packets with little beads in it. And they'll throw the right number according to a chart based on the size of the tire inside the carcass of the tire. So what happens is, as the wheel and tire as the tire is being installed, just before the final setting of the outer bead of the tire, a number of packets or a number of scoops of these beads are put into the tire. And what happens is, once the tire is sealed and the beads is set and the tire is inflated, once on the vehicle, when the vehicle starts to rotate, these beads automatically find the light spot of the tire and they cluster there. So they gather around the light spot of the tire and make that spot heavier. And that's how this automatic balancing works. But when you slow down below 55 miles an hour, these beads don't center in the right spot. So your tire is out of balance all the way from 1 mile per hour to 54 miles per hour. Now, once it hits 55 miles per hour or so, these beads balance the tire. And you're good until you slow down below 55 miles an hour. So this is a constant arrangement of these beads rolling around. They don't stick in one spot. When you slow down, they all fall toward the road. Gravity pulls them down. So they're always rolling around, banging into the carcass, and they cause chafing and rubbing of the inner part of the tire, which causes this tire dust. Now, the problem with the tire dust is when you go to inflate your tire, or you let air out of your tire through the normal Schrader valve, the valve stem, if you will, these little bits of rubber clog up the valve, and they cause the valves to leak. So now you have another problem. And so what do? Well, you install a different kind of tire valve with a filter to prevent the little bits of rubber from clogging up the sealing end of the Schrader valve. So this is what's happening now. So if you go to the tire guy and you say, hey, I'd like some tires, and and I want them balanced, and they go, okay. Now, if you don't ask them how they're going to balance the tires, you might get these beads. Kyle? Any comments, Kyle, on that?
Vince, well, yeah, I first of all, I got to tell you that my phone, for some reason, Vince, at the last part of the last commercial, has just started dropping out. So I am catching most of what you're saying, but there's little bits of it I can't catch. But on the beads, I was thinking about the dust myself. It's planned obsolescence, because that's going to continue to eat the inside of that tire up, regardless of the dust plugging up the Schrader valve. And eventually it's just going to wear your tire out from the inside out. Especially, I would think, if you're on anywhere near of rough roads.
Yeah. And so here's a way of looking at it, class. The faster you're going, the more important it is to have your tires and wheels balanced. There's no question about that. But I want my tires and wheels balanced all the time. From slow speeds to whatever speed I may be driving. And I don't like the idea of, what do you do with these beads? Once these tires are taken off the vehicle, then what do you do with these beads? Now, how many beads are we talking about? Well, the smallest amount, I looked up a chart, the smallest amount in ounces of these beads is 3 ounces for a small passenger car tire. For a larger tire, like maybe a pickup truck tire, we're looking at around 14 ounces of these beads. That's a pretty significant weight. If you think about it, what's 14 ounces? That'd be like a soup can or a can of corn, right? Rolling around loose inside your tire. That's an enormous amount of weight, in my opinion. Enormous. So, for most vehicles, and I don't want to skew the class, but let's say you have a tire. I'm looking at a chart right now. Let's say it's, I'm trying to find a common one. Okay. 215. Okay. 195/70. No, that's not a good one. That's half inch size. Okay. Here we go. I don't like that one either. Okay. 225/75/16. That would be like for a Silverado pickup truck. Well, actually it's a little small for a Silverado, but 4 ounces. Okay. So you might be putting 4 ounces or more of weight rolling around inside your tire. And what do we do with these beads? I don't know. There's no recycling plan, and there's something called externalization. And what that means is the manufacturer doesn't worry about it. They externalize the cost of dealing with the waste to everybody else. That would be, the American people. So the cost of dealing with these beads, and animals might like to eat these things. I mean, they look like little food pellets, because they're about that size. I would think birds would think that they'd be delicious until they try one. They certainly, look like they're food. So what happens to these trillions and trillions and trillions of beads that have been manufactured? I don't know. But I'll tell you what we do with them. We hate them. When a car comes in with these beads in the tires and we're putting a new set of tires on, we take all the old beads out and we put them in jars. And we have them all saved in these plastic jars. Now, what are we going to do with them? I don't know. Maybe we're going to reload shotgun shells with them or something like that. But other than that, what do you do with them? I don't know. I don't know. So that problem has been externalized from the manufacturers. And that's a big problem in the United States. Companies have manufactured deadly products, dangerous products, and they leave it up to everyone else to get rid of them. One example is, where do all these plastic bags go from the Chinese factory outlet? Where do they go? Where do all the soda bottles go from Coca-Cola and Pepsi? Where do they go? They go into the oceans, they go into the landfills, and they go into the highways and byways for everyone else to pick up. So that's called externalization, and that's one of the problems with these beads. I don't like it. Now, Kyle, any comments before we continue?
No, you're covering it very well, I think.
All right. So then, what about the lead weights? The lead weights that we used to use as wheel balancing weights. Well, some people would say, well, lead is deadly, it's dangerous. Well, that's absolutely true. There's no question about it. But what I've seen at every single tire shop, every single one, including ours, is the lead weights are taken off, and if they can be reused, they are reused. If they can't be reused, they go in a bucket and they get recycled. That means the lead gets melted down. They make new weights out of the old lead. That's what they do with car batteries and truck batteries. They recycle them. That's why you pay an $18 core fee on a lead acid battery, because the lead is worth somewhere around $18 or a little bit less for that battery. And they don't want it just being junked and thrown in the landfill. So they figure that if they charge you to not give your old battery back, that you're not going to walk away from that $18. You're going to want the $18 and then they can get the battery back and recycle it. That's how that works. Any comment? Kyle, have you seen buckets of wheel weights at the tire shops? Or
yeah, I collect them. Anytime I go to a tire shop where I know the guy, and I try to collect them because around here we can snag for salmon. And if you buy the hooks, the big treble hooks for yourself, when the salmon are running, and you can either do it a couple of different ways. I have a mold, but before the mold, I used to melt the wheel weights down and pour it in. I would cut the right kind of a cavity out of a potato, and I would fit the hook down in there, and I would pour the wheel weight lead around that that treble hook to be able to drop it in there. You can buy them already made up, but I just try to save some money, and I'd use wheel weights, or it makes excellent bullets if you the wheel weight lead. Once you learn how to cast it and case harden it, dropping it in cold water, and how to be able to melt the lead correctly in a ventilated area and all of that kind of stuff. I mean, every safety measure you can think of intact, so that you're not breathing the fumes. But anyway, they make extremely good bullets.
Mm-hmm. Right. And that's called, cast bullets. And you can do that yourself. You can go to eBay and you can look up, bullet mold, and you'll find that you can buy these molds, and they will have, let's say 4, 6, or 8, cavities, and you can pour the hot lead into them and make your own bullets. And bullet would be the part that goes flying down range. That's the bullet. A cartridge would be a completed assembly. That would be the brass, the powder, the primer, and the bullet. With tires, there's a bunch of reasons why tires and wheel assemblies don't balance properly. And I found out that there are percentages. The tire industry has figured out what percentage of problems arise from improper balancing. And here's what it is. So when your tire guy puts the tire wheel assembly on the balancer, and if he doesn't center it properly, there's a mechanism, there's a cone that will center the tire properly. If he doesn't do that properly, 60% of tire imbalance problems are caused by improper centering of the tire wheel assembly on the balancer. That's a human error, not centering the wheel, if you will, properly on the balancer. We'll be right back. There are human errors involved in balancing tires, and I guess that's why these ceramic beads have become a little bit more popular, because you take some of the human element out of the actual skill required to statically or dynamically balance tire wheel assemblies. Because all you have to do with the beads is just read the chart, look at the side wall of the tire, see what size it is, read the chart, and it'll tell you how many ounces of beads to put in, and you're somewhat done. Well, actually balancing a wheel tire assembly with wheel weights is way more complicated than that. And so there are errors that are made, and here are some of the percentages of those errors. So you can, and why am I telling you this? So when you watch that guy balance your tires on his tire balancing machine, you can pay attention and see if that person is actually doing it properly. So another problem is improper wheel weight usage, meaning about 7% of the tires that are balanced are out of balance because the wrong wheel weights are used. Now, there are wheel weights depending on the size, the shape and size of the rim. So, for example, an aluminum magnesium wheel has a wider rim than a steel wheel does. So you need to use the proper wheel weight for an aluminum magnesium wheel as compared to a steel wheel. Now, there's another problem, and that would be the balancer calibration. We check each tire balancing machine has a method for calibration, meaning let's make sure the machine is actually correct in what it says is a balanced condition. So if the balancer is not calibrated properly and often, then even though the display says the tire wheel assembly is balanced properly, it isn't. So we check and recalibrate our balancer maybe once a week, and that's really often. Typically, maybe once a month would be, enough. But we want to make sure ours is perfect so that when we send a tire out the door, it actually is balanced, because we want to make sure the balancer is calibrated. And there are tools for doing that. So what happens is, in our balancer, which is a snap-on balancer, our balancer comes with a special weight exactly for that machine, and that weight is screwed into a certain location on the drivetrain of the balancer. We put it in and we push the button that says balance or calibrate, and it will calibrate the machine automatically. Then we take that weight off, and then we're good to go for balancing a whole bunch of tire wheel assemblies. There are other problems, like, is the tire and wheel, once assembled, is it round or out of round? And if it's not round, then that causes 5% of these out of balance conditions. 5%. 5% is caused by the balancer calibration. And then the way of looking at this is, when we put a tire on a wheel, we actually spin it by hand on the balancer, and we see if it is perfectly round. If it's not, we try to find out why it's not round. Because if it's not round, that tire will go down the road like an egg. It will be eccentric, and it will never feel right. So before we put the wheels and tires on a vehicle, we make sure that it's round. There's another thing that causes about 4% of the problems, and that's called an improper lug nut torque. So what happens with a lot of tire guys is they use a torque stick, or they don't use a torque stick. A torque stick is something that limits the amount of torque that comes out of the impact wrench or the impact gun when they spin up these lug nuts. Well, we don't do that. We torque them by hand, and that way, when we use a torque wrench, and that lets us use the proper torque on all 4, 5, 6, 8, 10 lug nuts, depending on what the wheel is. So 4% of the problems are just from that improper lug nut torque. So what I've seen many, many times, and maybe this doesn't happen as often in Kyle's area because they seem pretty sharp out there, a guy will take the wheel, put it on the vehicle, take one lug nut and just run it all the way tight. Boom. And by doing that, you can bend the wheel. And that would cause about 4% of the problems with wheel balance. Kyle, have you seen that happen in your life where the guy just runs up tight the first lug nut?
Oh, yeah, sure. In fact, I saw we had a new tire guy one time at the dealership I was working at, and he thought he knew how to put tires on. And I saw that the first time, and I went over to him and I said, that ain't going to happen again if you want to keep working here. He said, well, why? It's just getting it centered on there. I said, no chance. I said, you're going to run that gently, and then you're going to come it gently. And I basically showed him what we talked about last show, how to diagonally tighten those tires and then bring it down and then use your torque wrench. Mm-hmm. So it's
when we come back, you had mentioned last time that there's something that you and I don't do that we slightly disagree on, and that is the use of lubricant. And I want to talk a little bit about that when we come back and why I do it. And I think conditions might be different out here because of road salt. We'll be right back. Kyle's in the front of the classroom at the blackboard. I'm delighted to be broadcasting with Kyle. We're talking about tires and wheels and balancing and problems and et cetera. And one of the things that also happens with wheels in the balancing arena is bent wheels or bent rims. And we've seen this. Even aluminum magnesium wheels. So hitting a pothole, bang, it can bend a wheel. And you might not notice immediately after that. It might take a few miles and go, Jesus, it doesn't quite feel right. And what happens is the wheels can get bent. That's steel wheels, aluminum, magnesium wheels. All wheels can be bent by hitting a hard object at the right speed. Kyle, have you experienced that?
I have. I've seen it many times, Vince. And the crazy thing is the narrower the sidewall, the closer the rim is to the ground, the more if you hit a pothole, the more apt you are to either break a belt in the tire and cause it to start running out of round, or to bend the rim. But what you said about putting it on the tire machine, making sure everything is square, and put in correctly and tight and flush, and spinning it by hand, that's always a wise idea if you have one. If you're doing this by yourself, it helps you. If you put it together right, and you spin it, and you don't see it, you see it a little bit out around, you start looking carefully. The first thing is you double check to make sure that you put it on there right. Because we're humans, we make mistakes. Even though we think we might have done it perfect, there might be times when you didn't. You caught the lip of the cone off of the edge of the tire, and it's not perfectly balanced as it's going onto the tire balancer. So you check that first, and then like you said, you check the run out, where the tire is, if it doesn't look like it's running straight. You look at the edge of the rim as you spin it by hand. You can see if it's and out. And in that case, there's no what we be able to bend. A lot of times I have actually seen where people come in, Vince. One time it happened with a lady that had a magnesium rim on a Pontiac that she was driving, and she had a tire had a slow leak in it. Well, when we put the tire, started checking, there was no leaks in the tire, and there was a crack in the rim. I couldn't believe it was still together, but there was a slight crack in that magnesium rim, and that was causing her leak, and she had hit a pothole.
And we've seen that as well. And so one of us here at the farm was driving down a road, and it was getting dark, and the highway department decided they were going to repair the road. And what they did was they took one of these machines that grinds off, let's say, the first couple of inches of road, and they take that material and they put it in a dump truck and they haul it away. Well, when they ground off part of this road, they ground it off perfectly square with the road, and they didn't mark it. So it was, let's say, a 55-mile-an-hour zone, and it was kind of winding, a country road, 55 miles an hour, and they didn't mark that they were working on the road. And so you're driving along and you don't expect to hit a 3-inch rise in the road. You don't expect it. Or a 3-inch drop in the road. Or a drop and then a rise in the road. So at 55 miles an hour, you can bend wheels. You can damage the belts. Break the belts on a steel belted tire. And that's what happened to us. So multiple wheels were damaged, and I think 3 out of 4 of the tire belts were broken. And of course, I called, the highway department. They said, "Oh, there's no sign." I said, "No, there's no sign." And they said, "Yeah, we just started that today." And yeah, I guess they were in a hurry and they left, and there's nobody there, and there's no sign that there was road work. And so I said, "So I've got this damage. So I'm going to complete the report, and I'm going to be compensated for the damage." Now, why am I telling you this, class? Because when the highway department does things like that, and they cause hazards, and this is an intentionally caused hazard. Now, they didn't do it in order to damage people's equipment, but they did it intentionally, and they didn't mark that they did it. So we have proof that it wasn't marked. We have proof of the road conditions, and they're going to pay for the damage. Now, they're insured for this. And the woman who I called at the State Department was really concerned. It's like, "Oh yeah, they just did that today," and yeah. So they're aware of these kinds of things because people make mistakes. But that doesn't mean you have to suffer the damage. That doesn't mean that you have to pay for it. So when they inflict conditions like this on you, and your equipment is damaged, you can go after them, and they're insured for it. And I plan to be compensated for the tires that have the damaged belts and the bent wheels. I expect to be compensated for that, and I will be. Now, it may take, a couple months, but I'm going to pursue it, and I'm not going to yield. So you can too. So you call the Department of Transportation, you call the county, and you find out where, how to file the claim, and then file that claim. Now, one of the things that I mentioned, Kyle, have you ever had that where you filed a claim against the, road maintenance people?
No, I haven't, Vince. I haven't ever done that one.
Okay. Well, and you can, okay, if it's a bona fide reason, I would file the claim. I absolutely would. So it's not like, and I wasn't driving, it was somebody else in the family, but, and it's not like, we're careless and reckless drivers. That's not the case at all. The case is, the conditions were perfect for not being able to see that they ground off part of the road. That was the case. And it's not like a cat, we could have seen a cat going across the road, or a dog, or a trash can or something like that. But this is just a grinding off of the road surface. I wanted to mention that the reason, there's something else that I do, regarding the lubrication of the lug nuts and the lug bolts. Here in Missouri, we've seen a condition that we've never seen before. And that is that wheels on the rear of vehicles get stuck on the vehicle. And we, unbolt them, remove the wheel bolts, the lug nuts, etc. And the wheel won't come off. And what happens is these aluminum alloy wheels get cemented, glued, rusted on, whatever you want to call it, corrosion, because of the road salt. They don't want to come off the axle. They do not want to come off. Have you ever seen that, where you've actually had to hammer them and lubricate them and heat them and to get the wheel off the vehicle? Have you ever had that problem?
Oh, yeah, absolutely. In fact, I just took my studded tires off of my car and my Toyota. It's a little Camry. Anyway, I took the wheels and tires off of it and swapped it back over, took the studs off, and went to my normal summer tires. And interestingly enough, especially if the car has these little rings that fit around they go on the inside ring of your steel rim. It tends to just always be that. And I have had them with pickup trucks where literally you had to have a sledgehammer to break them loose, crawl underneath their small sledgehammer and hit them I hit mine usually on the inside and will spin the tire around while I beat it loose. But with this little car, there's that inside lip, and the rim fits over that lip, and then it lines up pretty perfect with the rest of the lug nuts, because you get the lug nuts on there, other than you got to make sure that they're turned left and right. But as far as the center of the circle that they're running in, they stay concentric. Well, the rim tends to rust to that little lip that's on the hub assembly on the back of your car, and it is seemingly always the back. Most of the time when it's a little car like that, I can sit down and kind of lean back and kick one side of the tire or the other side of the tire back and forth a couple of times, and it'll bust loose, which it did yesterday. But then I do tend to lubricate that little steel rim in my car, and my wife's car has it as well. You take a little bit of grease, and I'll put it on the inside of that rim, just so that hopefully will not be a problem next time I have to swap them out. But we have the other thing, Vince, we were talking about tire wear last time. This is an interesting thing. I was talking to one of the guys at Costco one time. I bought some tires there, and they were putting them on, and they came out with a 60,000-mile warranty on these tires. And I thought, boy, that's great. And I asked him, I said, don't you guys, are these tires, compensated somehow? If you, cause they chip seal the roads around here to harden them. So they will put the asphalt down, and then what they do is they mix tiny bits of rock, chips of rock, with this kind of, I'm going to guess, I'm not sure exactly the chemical composition, but it's like an epoxy. Anyway, it's mixed with these rocks, and they set that on top of the asphalt, and it makes the road last longer, but it will eat your tires up way faster. And I asked the guy at Costco, I said, well, don't they, figure that in when they're, especially in this area? And he said, they don't. And I've told them, I've actually called the company and told them that around here with chip-sealed roads, there's no chance that those tires are going to last 60,000 miles. And they told him, said, well, nobody really keeps their car hardly that long anymore, and they don't keep the receipt or try to, pursue a warranty against the tire if it doesn't make 60,000 miles. And I thought that was an interesting comment, but it's an interesting corporate decision as well.
Mm-hmm. I had some Kumo tires at one time, Kuhmo, and I thought they were okay. And one of the steel belts failed. So the tire became eccentric, and it would thump down the road. So I called Kumo, and then I checked the other tires, and I had a problem, I think, with two of them. So I called Kumo, and they said, "Oh yeah, bring it to a tire shop. Yeah, there's one in Springfield, which is like a 100-mile round trip, and have them look at it." And I said, "Well, I've got a tread depth indicator, and the tires are about three quarters remaining." And they said, "Yeah, well, we'll warranty. That's not a problem." And I said, "So before I go all the way to Springfield, what is the warranty?" And they said, "It's going to be like $20. They'll give me $20 or $22 for the tires." I said, "Really? So that's all I'm going to get? It will cost more in fuel to go there than I'm going to get back. And I have to buy 4 tires because it was on an all-wheel drive vehicle." So back to these tires. And let's say that I had one tire on this all-wheel drive vehicle. It happened to be a Mercedes for E430, so it's 2000 model. And it's a great little car. But it's an all-wheel drive. This particular one's called a 4MATIC, the number 4, MATIC, which means all-wheel drive in Mercedes nomenclature. So this antique or almost antique car has this all-wheel drive system. And when you have all-wheel drive, all 4 tires have to be the same. They have to be the same make, they have to be the same model, they have to be the same size, and in my world, they have to be from the same manufacturing facility. So even though they may be a specific brand, you want them from the same factory. That way they're the same size. And why is it important? Well, if you do some research, you'll find out that the automobile manufacturers will say that if you have an all-wheel drive vehicle, the tires must be within 2 30-seconds of an inch from smallest to largest. So if you have 3/4 wear, as I did left on the tires, and let's say they were 12 30-seconds of an inch tread depth originally, and I had 3/4 wear remaining, that means that I've worn off roughly 3 30-seconds, which means that it's outside the maximum limit of being within 2 30-seconds of an inch from smallest to the new replacement tire, which would be the 12 30-seconds. That means that if I wanted to protect the drivetrain of this Mercedes and not destroy the transfer case, I would have to replace not 1 tire that was bad, 4 tires that were bad. That's the problem with all-wheel drive vehicles. When you have 1 tire that fails, you need to keep all of them the same size, which means you're probably going to buy 4 tires. So Kyle, what are your thoughts about that? Have you experienced anything like this?
Oh, yeah. In fact, Vince, it's interesting. Around here, Subarus are extremely popular, and they're very durable, very tough little vehicles. They last a long time. They do real well in the ice and snow around here. I've owned a couple of them, but I went away from all-wheel drive just for that very reason. My pickups are 4-wheel drive, and all the other times we run front-wheel drive, and as long as we have good tires, we can get by. But the only Subaru transmission I ever saw go out completely was because the lady did just exactly what you're talking about. She ran a tire. She had a tire that had a flat, and her spare was so small, it was smaller than the one tire she had in there. And she ran that for like, I can't remember, 60 or 80 miles is all it took. And her car had a lot of miles on it, like 200 and, if I remember, it's like 220,000 miles on it already. But anyway, it took the transmission out. It was gone. So anyway, that's my thought on it. I went away from all-wheel drive cars just for that reason.
Yeah, and we have two. We're not going to buy any more. Now, four-wheel drive is not the same as all-wheel drive. Four-wheel drive is a lot tougher. The running gear, drive train is much more substantial in a four-wheel drive vehicle than a two-wheel drive vehicle. So all-wheel drive means wet, dry, snow, ice. All four wheels have the potential for propelling that vehicle. And they're all going at slightly different speeds when you go around a curve. The inside wheels go more slowly than the outside wheels. The outside wheels try to catch up and they can go faster. So if all four wheels are connected to the drivetrain, there's a potential, and it's not always the case, but sometimes it's the case, where they're fighting, the tires are fighting each other. Well, with an all-wheel drive vehicle, you really need to have the tires the same size to prevent some of that fighting, or most of that fighting. With a four-wheel drive vehicle, they can take it. You can actually have, BF Goodrich on the front, and you can have, Michelin on the back. Assuming they're the same size, on the sidewall, you can do that, and it'll probably be okay. That is not the case with an all-wheel drive vehicle. All-wheel drive vehicle, you need to have all four tires, the same make, model, size, and in my world, from the same factory. So to compensate for these expensive problems, if you get a flat tire or you get a belt that fails, we buy 5 or 6 tires at the same time, and we buy multiple wheels, and we rotate the new ones in with the old ones so that they all have about the same wear. So if one of them gets destroyed, we're still okay. We don't have to buy 4 more. And that really works for us. But it's really handy if you have your own lift. I'm just getting back to the stuck wheels on the rear axles of vehicles. It seems to be a problem, at least in Montana and Missouri. It's because of the road salt. And so here's what we do. We take a fine film of grease. And it can be synthetic grease, it can be conventional, and we put a fine film of grease on the hole, the center hole of the wheel, where the wheel attaches to the axle. And the reason for that is that seems to be where it gets stuck. And we put a little bit on the back of the wheel, but we make sure that we don't get, and I'm talking about a very thin film. So kind of apply some grease and then wipe it off, that kind of a thing. And the idea is to reduce the corrosion so the wheel doesn't stick to the axle. And that seems to help a lot. And what we do to get these wheels off, and you can experience this, class. If you have a flat tire in the rear of a vehicle, you may find that you can jack the car up if you know how to do that, and you can loosen the lug nuts, and then you can try to take the wheel off, and it may not come off because it's rusted on. And that's a heck of a time to find this out, because if you don't have some lubricant and a way of heating up the wheel like an electric heat gun, that kind of thing, that's what we do. And we gently tap with a large hammer and a 4x4 block of wood on the tire itself to kind of gently get that shock the wheel axle assembly once the lug nuts are removed, to after we lubricate it, to get that wheel off, because we don't want to bend the wheel. But it can be a real problem if you have a flat tire and you can't get your wheel off your axle. So I just wanted to mention that. Kyle, we've got a call. Martin in California, welcome. You're on with Kyle and me.
Yeah, I got a 94 Oldsmobile fuel injected, and it runs like a champ, but in the morning it dies 2-3 times. I have to let it warm up for maybe 4 or 5 minutes, and then it runs like a champ, but it keeps dying on me, and it acts like the old cars. You have, you use a choke to keep it going, but I don't know what keeps it from running constantly,
Give me a hint. What kind of a Oldsmobile? You have a 94 Oldsmobile. What model? What size engine do you have?
It's a V6 3.0. Let's see, cruise. It's a station.
Okay, well, it's a V6 3.0. Okay, so what service have you done? Have you done things like how many miles on the spark plugs? How many miles on the air cleaner? How about the PCV system? Have you looked at that?
Yeah, I cleaned all that up about 3-4 months ago. And I cleaned the massive air cleaner, the
mass air sensor, yeah.
Yeah. So other than that, I don't know what else to do. Change the oil, I always do that. But other than that, I understand some people will say it's a gas sensor, that it gives it more gas if it's cold. It acts like a choke, but I don't know where that would be.
Well, there are temperature sensors. There's a coolant temperature sensor. There are many sensors in these vehicles, and based on the outside temperature, based on the block temperature, there's an algorithm that supplies the correct amount of fuel to your engine. So if that sensor is not working properly, that could cause a problem. But also a vacuum leak could cause this kind of a problem. So you could have a vacuum hose that is either not connected properly or has a crack in it. That could cause it. You could have a plugged fuel filter that could cause it. You could have one or more spark plugs that are fouled. That could cause this. You could have a plugged up air cleaner. And you mentioned that you cleaned the mass airflow sensor. Now, how did you do that, Martin? How did you clean the mass airflow sensor?
Oh, they got this spray thing. You can spray into it, and it acts real sensitive then, on stop signs and so forth. And that's...
Well, the way the mass airflow sensor works is there's a heated element, and based on the volume of air that goes across this little heated element to cool it, that determines how much air is coming into your engine, and that tells the computer how much fuel to mix with the air that's going in for the precise, roughly 14.1 parts of air to 1 part of fuel. That's what that is all about. And how did you clean it? Did you clean it with the engine running or not?
I cleaned it when it was dead, and then I sprayed it while the engine was running, and then it'll run wild for a second or two, and then I discontinued it.
Yeah. The way I do it is I try to clean it with the engine not running, because I don't want that little element to be heated, and I don't want to shock it with the cold spray of the cleaner. So there is a mass airflow sensors cleaner. There's also a carburetor cleaner, and I believe they're very similar, and you can use, in most cases, either one. I do it when it's cold, but I don't use a lot. You only need a very little amount. Just that's it. That's all you need to do and you need to spray that in the center of the mass airflow sensor plumbing. And that should take care of that problem. But it sounds to me like you have it could be a lot of things. It could be spark plugs. It could be a vacuum leak. It could be one of the sensors for the coolant. Now, what I would do is I would go to the internet and I would type in 1994 Oldsmobile 3.0 and describe your problem in very few words, and you'll find a lot of answers. But when you pulled your spark plugs, you said you cleaned your spark plugs, or did you just replace them?
No, I cleaned them.
How did you clean them?
Oh, I got one of these sandblasters, the old type, and I put them in there, and then I regapped them, and they weren't burned or anything, so I just reused them.
Now, when you say you regap them, why did you have to regap them? How many miles were on them? Because typically spark plugs don't show that much wear, between the center electrode.
I just, used the gapper and just to make sure, but there wasn't any, readjustment at all really in it. So I just took assurance that it was right.
Okay. Well, here's what I do. I always, with brand new spark plugs, I always check the gap. And there are different kinds of feeler gauges. There's a flat feeler gauge, there's a disc feeler gauge, and there's a wire style feeler gauge.
Yeah, that's the one I use.
The wire?
Yeah.
Yeah, that's the one I prefer too for spark plugs. But they'll all work. But the round one, the wire type is my preferred, go-to choice. But, so did you look up the exact gap for that particular vehicle?
Oh yeah, absolutely. That's what makes the difference.
Yeah. And how far out of gap was the largest variance from factory spec?
Oh, it was hardly nothing. I mean, it was so close that I really didn't need to gap it, but I just checked it to make sure. That's all it amounts to.
Mm-hmm. Mm-hmm. Okay, well,
sounds like
it's difficult.
Sounds like I have to do a lot of rechecking over the whole engine again.
Well,
let
me answer something here real quick. Have you checked your idle air control valve?
No, I don't even know what that is.
Well, there's on a lot of these computerized cars in the early ones, they had a fuel pressure regulator, but they also had an idle air control valve. And so look that up for where it is. I can't remember exactly where that's at on that early of a model one. But sometimes if your idle air control is malfunctioning, it will not allow your car to want to run right, especially when it's cold. But when the engine heats up, then the idle air control valve will kick in and start working correctly.
Okay, I got a manual. I'll look it up through that, and from there.
Kyle is absolutely correct. Kyle's absolutely correct. And you're looking at about a $20 part. That's typically put in with just a couple screws. Literally 2 screws and, I don't know, maybe less than a half an hour if you've never done it before.
Where is it located at?
Let's see. Well, they're different. It's usually on top of the engine, but,
okay.
Let me see if I can find it for you. I'm going to see if I can find a picture of it.
Well, that's all right. I'll look it up in the manual. It'll probably show it there pretty clearly.
It will. It'll show it.
At least
and that is something worth looking at. But one of the questions that I had was when you pulled out your spark plugs, did you see any variance from one cylinder or one spark plug to the next, or did they all look the same?
They all look the same.
Good for you. So it sounds like you're on top of your maintenance. And that was one of the things that Kyle and I were going to talk about today, that you can read spark plugs and you can look at how well each cylinder is working compared to all the others. And I have a feeling that you do that. Is that correct?
Oh, yeah. Because it's an old car. And these new cars they scare me because I don't know what the hell, these computers and so forth. I'm not into any of that, but this is a simple car, I think. I mean,
sort of simple.
Yeah. So
it's got a computer, but yeah.
Yeah, but other than that, I'm very happy with it. It runs like a top. Other than that.
And one last question I have for you. This spark plug cleaner that you have, is it a Vixen, Vixen brand?
Oh, I don't know.
It mounts on the wall with 2 screws. You have a push button. It uses an abrasive compound. It's got a little bag. You push the spark plug in the top. You hook it up to a compressor hose, and you turn your face away so you don't get blasted with dust.
Yeah.
Okay, that's the one we have. It's made by Vixen, Vixen. I bought mine back in the 70s, and I use it. But when you do this, you need to make sure that you get all the abrasive out of it. How do you do that?
Oh, I never did that. It is so old. I just use it on my car. So,
well, yeah, you got to get the abrasive out of the. You got to get the abrasive off the spark plug threads, off the center insulator, and off the side insulator as well. And so here's what I do.
I clean it with gas.
Okay, but you do. All right, that's dangerous, but it'll work. But you do wash it off before you put the spark plugs back in the engine, right?
Absolutely. Yeah.
Okay. All right. That's critical. Here's what I do. I have cans of Walmart spray lubricant. They're about $2 a can. What I do is I take the compressor and I take the spark plugs outside and I blast the air away from me and I blast all the abrasive I can get off from the threads of the spark plug and the center electrode. Then I rinse them with the spray lubricant, which I believe is clean and relatively pure, and that gives me a final rinse without dipping them in gasoline. You might want to consider trying that, Martin.
Okay, thank you very much for the lead.
All right, Guy, thanks so much. And George, you're on next. So we've had problems like that on vehicles. They are typically vacuum leaks, cracked vacuum hoses, worn spark plugs. They are a plugged fuel filter, weak fuel pump, or, as Kyle said, malfunctioning idle air control, which we have seen once. Let's see. I think you're right on the money, Kyle, with that one. George in Mississippi, welcome.
Good morning, guys. I am replacing the deck on my trailer, and I was wondering if you knew of anything that I could put on it to where it won't rot again.
Yeah, you can put Thompson's water seal on it, and a lot of people have done that. I've got a trailer that I'm going to be redecking. It sounds like that's what you're talking about, right?
Yeah.
Okay. I happen to have a John Deere trailer. It's roughly a little over 6 feet wide, 8 feet long. And what John Deere did was they took plywood, 3/8 of an inch treated plywood, and they cut it into 2 foot wide strips, and they just shoved it into a channel, and that is the entire decking. But I don't like that. So what I'm going to do is I'm going to use pressure treated wood, and I'm going to replace the decking with pressure treated wood, and I'm going to leave it outside in the sun for a while and make sure that because the wood's typically green when it's pressure treated, it's still soaking wet. Then what I'm going to do after it dries out is I'm going to put a water sealer, like Thompson's deck sealer, on it, and that's it. And that's what a lot of guys do. Have you considered that?
That's what I got. Mine's 6x12, and I'm putting 2x6 boards on, and get it back going. Just finished taking it off and got the bolts out, getting ready to put the deck back on.
Mm-hmm. And what are you going to do about the wheel bearings? Are you going to take the hub caps off and repack the wheel bearings?
I recently did that about a year ago, but I guess I need to get back in there and redo that again.
Yeah. Here's what I do. I mean, as a quick way of doing it, I'll pull those little caps off, the hub caps off, and I will, when I pack wheel bearings, I'll take grease and I'll put one of those latex gloves on, and I'll put like a tablespoon of grease in the palm of my hand, and then I will force the grease through each needle of the wheel bearing until it comes out the other side. Is that what you do?
Yeah, I make sure that I get all the bearings greased really good before I put them back in there.
And then what I do is I add extra grease in between the inner and the outer wheel bearings in the wheel hub, and then I put the wheel bearings in and I tighten them, and I like a little bit of play. And this is an art. I'd like to hear Kyle's comments. You don't want the wheel bearings too loose and you don't want them too tight. If they're too tight, they can fail. If they're too loose, they can fail. So I don't really want to say how to do it on the air, because if someone leaves them too loose, you can have an accident and a failure. And if they're too tight, the same thing. Kyle, do you have any comments about greasing wheel bearings and putting extra grease in the center of the hub between inner and outer?
Yeah, same kind of a thing, Vince. There's a real dance with tightening those up and learning how to. I tighten mine down, and then I might just back it off just a tiny bit, just to where I can just feel it. The other thing that you can consider for your deck of your trailer that I have used is a product called Man of War. And I have had extremely good luck with that on decks of vehicles and stuff. I have had better luck with that than I have Thompson's Water Seal. And I've used them both. But anyway, that's just the thought on it.
And that Man of War is brand new to me. That's a new product to me. That's great. George, back to you.
A friend of mine suggested, after I bought everything for it, he said, maybe you should go back with some composite on there. That way you don't have to worry about doing it. I said, well, that might be an idea for the next time, but I already have everything, and I'm not going to bring it back and then go look for it.
How long did the first deck last?
Well, this is actually the second time I'm decking it. So I think it's been about 10 years since I decked it the last time.
Kyle, what's your experience? How long do they last for you?
Well, I'm still going on mine. I would say right at now 12 years, and it's doing fine. In fact, my son-in-law just borrowed it the other day. I am about ready to put some more of that Man of War on there, but just for the sake of resealing it, because this particular trailer sits outside, so it has everything on it. I haven't got a place to be able to park it underneath anything.
We've got a trailer that we bought around 1989, and it needs a couple boards replaced. Not all of them, just a couple. So if you use good quality wood, it can last quite a long time. So I don't know, but the John Deere with the plywood, and that's going to be on its third deck in, let's say, 35 years. George, thank you for calling. Thanks for being part of the class.
Thank you for the information on the tires. I really learned a lot.
Oh, great. I'm glad you did. And Kyle, thank you for your expertise and being with us and sharing your knowledge. And I think you're right on the money with the idle air control.